All right, today we're going to discuss formulas involving polygons. Hey, if Polly's gone, did her angles go with her? Okay, that's a bad one, I know. All right, okay, so first we need to do some defining of things. First of all, a diagonal of a polygon is a segment that connects any two non-consecutive vertices. So you'll see here that segments PR and segment PS are in red, and those two segments are diagonals. Okay, a diagonal is not a side. Okay, so basically you're just connecting to vertices that are within the polygon but non-consecutive. Okay, so let's take a look at diagonals and triangles. So in a triangle there are 0 diagonals, and because any vertex cannot be connected to any other vertex but by a side. Okay, within a quadrilateral, if I choose a vertex, such as the lower right-hand vertex, I can only connect one diagonal, and I create 2 triangles. From a pentagon, from one vertex, I can create 2 diagonals, which creates 3 triangles. From a hexagon, I can create 3 diagonals, which creates 4 triangles. So, why are we doing this? Well, we're going to take the information we know about the sum of the angles of a triangle adding up to 180 and derive some more information about polygons. Okay, Rowdy. Okay, so let's take a look at something. The number of sides. Triangle is 3, number of triangles is 1, the sum of the interior angle measurements is 180. Within a quadrilateral, there are 4 sides, 2 triangles, and the sum of the interior angles is 360. Pentagon, 5 sides, 3 triangles, sum of the interior angles, 3 times 180, which is 540. Hexagon, 6 sides, number of triangles is 4, 4 times 180, or 720. So an n-gon, which is what we use n for the number of sides, the variable. So the number of sides is n, number of triangles, well, it's going to be n minus 2. And so the sum of the interior angle measurements is n minus 2 times 180. So basically, we've derived a formula. Okay, so Theorem 55 states the sum, S sub I, of the interior measurement of the measures of the angles of a polygon with n sides is given by the formula n minus 2 times 180. You're going to have to memorize that formula. So in this picture, the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D plus the measure of angle E is equal to 5 minus 2, which is 3, times 180, which is 540. So if we take the exterior angles of a triangle, so an exterior angle we talked about is when we extend the side. So let's say we have a 60-degree angle and a 85-degree angle and a 35-degree angle, and we add those up, that comes out to 180. Now, if we take those exterior angles of 120, 95, and 145 and add them together, we come up with 360. So that's for triangles. Now, imagine what are the exterior angle sums for a quadrilateral. Look at this. Okay. Alright, I was too fast on the trigger there. Let's go with the pentagon. Try again. And that adds up to 360. Though, I have a mistake, which is I put one too many 45s in there. So there we go. That adds up to 360. Okay, no matter how many sides you have on a triangle, or excuse me, on a polygon, the sum of the exterior angles is always 360. So, you could have 100 sides. The sum of the exterior angles is always going to be 360. Okay, so this formula here is the formula of diagonals, the number of diagonals that can be drawn in a polygon of n sides. Another way of stating this formula is that it's also n squared minus 3n over 2. So either way, you can use either formula to figure out the number of diagonals that can be drawn in a polygon of no matter how many sides. Okay, so in this picture, we have a polygon, and we have, it is a 1, 2, 3, 4, 5-sided, so it's a pentagon. So the sum of the measures is again always n minus 2 times 180. So 5 minus 2 times 180 becomes 3 times 180, which is equal to 540 degrees. So a pentadecagon is a 15-sided figure. So number of diagonals that can be drawn, again, n times n minus 3 times divided by 2. So 15 minus 3 times is 12, all over 2. Well, 12 times 15 is 180, or else you can factor this here too. So you can do this and end up with 6. Either way, your answer is 90. Okay, what is the name of a polygon if the sum of the measures of its angles is 180? So you're going to plug in n minus 2 times 180 equals 1080. So from there, you take out your handy dandy calculator and you divide each side by 180. So n minus 2 is equal to 1080 divided by 180. and that is 6. Now you're going to add 2 to each side, so n is equal to 8.
That's all, folks.
All right, stay healthy and do your assignments.